So, hello everyone, we're going to solve another question from this book over here. Okay, so this question goes like this. So he gave us this triangle over here, and he told us that AB is equal to AC, and this BP is the bisector of this angle. So both these angles are equal, and this is the whole angle over here. Okay, so this is half of the angle B. Okay, and this is the median point. It might not seem from my bad drawing, but it is the median point of BC. Okay, and these two sides over here are equal. So he's asking us this question: if BC, the base, is fixed, and we start like pushing down A, okay, pushing down until A is in the point M, okay, what happens to the point P over here? Okay, so try thinking about this question by yourself. Like, do you think P is going over there, or it's going to fold in C? What do you think will happen? So you can see that this question will involve a bit of angle, so trigonometry, a bit of geometry, okay, and concept of limit, because the limit, when this approaches this, what will happen to P? What will it approach? So a very nice question for the max exam, okay? So to solve this, I'm going to do it this way. I'm going to do it as if I had an analytic question, analytic geometry, okay? So as if I had this point over here. So this is the origin, and this is the y-axis and the x-axis, okay? So note here we have a line. I'm going to compute this line. How do I compute it? Well, look, you see this over here, this is the angle, right? But it is like the linear coefficient. So what do I mean by this? Well, this is a line that passes through the origin of my system. So it goes through the point 0 and 0. And I'm going to call this coefficient over here A, okay? So this is A. Okay? So what is A? Well, tangent of theta, it's equal to A, okay? Because remember, this coefficient over here is the tangent of this angle over here, okay? So if I know that a line is equal to y ax plus b, now notice it goes through the point 0 and 0, so b is 0, right? And a, well, a is a, right? So we'll have that y is equal to ax. So this is our line over here. But I want to make a condition, okay? What condition am I making? For x is smaller or equal of m, okay? What is m? Now m is this point over here, is the median point, okay? So I only want this line over here to exist for x is smaller than m. After it, and you can say bigger or equal to 0, okay? Because we don't care, because the line y equals ax would be continuous over there, right? But we only want this part over here, okay? So this is for the first line. Now what about the second line? What second line? This over here, AC. How do I compute AC? Well, you notice that AC, this angle over here, is the same as this angle over here, okay? It's just like if this was over here, this one is sad, right? So this one is like sleeping over here. So we are going to take what as this is a positive, this is going to be a negative, right? Because it's falling. So this is going to be minus a, okay? Minus a, it's linear coefficient. And b is not going to be 0. We are going to have a different number for b. But we can find it. How can we find it? Now notice, let me just save this first over here. This is our first equation for our first line, okay? We are going to put it all in Desmos after this. So for the second line, how do we start? Well, the same thing, right? Y equals the linear coefficient. Now notice that the linear coefficient over here is minus a, okay? Minus a is linear coefficient, because we're actually not taking this one over here. This is the minus a, okay? Because it's falling down, okay? So the minus a multiplied by x plus b. How can we find b? Well, we can find it by having a point, and we have a point. This point over here. This point is what? It is m and what? M and what? What is it in the y? Well, you can look over here. This point is part of this line over here also. So you can use this equation. So as x is m, so you'll have that y is equal a multiplied by m. So here it is am, okay? Okay, because as y equals a multiplied by x, and your x is m, and this point is part of the both of them. So when a multiplied by m is equal to minus a multiplied by x, but x is m, plus b. So our b is equal to 2am, okay? Remember that m is the medium point, okay? So our second equation for our second line is equal to what? Is equal to minus a multiplied by x plus b, but b is equal to 2am. So this is our second equation, okay? Now for our third and final line that we need this line over here, which will be the most difficult to compute for now. How do we compute this line? Now I'm going to need you to remember a formula. If you have the tangent of a plus b is equal to what? The tangent of a plus tangent of b divided by 1 minus tangent of a multiplied by the tangent of b, okay? This formula from trigonometry, okay? The formula for the tangent of a plus b. Why do I need you to remember this? Because I'm going to use it to find the linear coefficient of this line over here, this linear coefficient, okay? It's different than a, okay? This one we knew that it was a because we know that it is an isosceles triangle, so this linear coefficient over here is the same as this falling one, but as this is positive, this is negative. But how do we compute this one? We are going to use this. After we find this, it's easy. Why? Because we have a point and we are going to have the linear coefficient. So we just use y equals ax plus b again, and we find this formula. Okay? So notice, what am I going to say? I'm going to call, so this is theta, but this is half of it, right? Theta divided by 2, and this part over here is theta divided by 2, right? So the tangent of theta divided by 2 plus theta divided by 2 is equal to what? To the tangent of theta divided by 2 plus the tangent of theta divided by 2. I'm using this formula over here, okay? Right above me. 1 minus the tangent of theta divided by 2. You can find this in any trigonometry book, okay? It's the formula, like the most common are the sine of a plus b, right? And cosine of a plus b. You need to know these formulas for the max, okay? This and this formula, okay? I didn't see them use a lot of this, but these two over here, they always use the sine of a plus b. So how do we go on solving this? Well, the tangent of theta divided by 2, plus theta divided by 2, it is what? It is the tangent of theta, right? But remember, tangent of theta is a, because this tangent over here of this angle over here is the linear coefficient of this line. So this is equal to a, right? So I can say that a is equal to the tangent of theta divided by 2, well, plus theta divided by 2, so multiplied by 2, 1 minus tangent of theta divided by 2 multiplied by the tangent of theta divided by 2, so it is squared, okay? Now remember, what is the tangent of theta divided by 2? This angle over here. This is theta divided by 2, right? It is the angle that this line is making. So the tangent of theta divided by 2, I can call it what? W, okay? W is the linear coefficient of this black line, okay? So it is y is equal to w x plus b, okay? It could be a, it's just that I used a already, okay? So remember that this is what we are looking for. So I'm going to call it w, okay? So a is equal to 2 multiplied by w, which is the linear coefficient. It was the name that popped in my head. And w squared, right? Because the linear coefficient is equal to the tangent of this angle. So now we are going to have what? A minus a w squared, I'm just multiplying over here, is equal to 2w. So I'm going to join them, all of them in one side. A w squared plus 2w minus a is equal to 0. Now I'm going to need to solve this quadratic formula, okay? So I'm going to have minus 2 plus or minus square root of 4. I remember it was minus b plus or minus delta divided by 2a, okay? Delta is what? Delta is equal to 4a, it is b squared minus 4ac, okay? This is the formula, the quadratic formula. So here we have 2 squared, which is b. I'm just doing these parts fast because I think you already know them. So 2 squared is 4, minus multiplied by this minus over here will be plus 4, a multiplied by a, so a squared divided by 2a, okay? Just use this formula over here, putting in place of delta this b squared, and this is b, this is c, and this is the a part of this formula over here, okay? So what are we going to have over here? Minus 2 plus or minus square root of 4 multiplied by 1 plus a squared, okay? I just took the 4 out over here, okay? If you multiply over here 4, okay, same thing. So now I can take the square root of 4 alone. So it is minus 2 plus or minus 2 square root of 1 plus a squared divided by 2a, okay? So now I'm going to divide everything by 2, so I'm going to have what? Minus 1 plus or minus 1 divided by 1a squared divided by a, okay? Now here comes the question. This is, we have two answers for w, right? What one are you going to choose? Now notice if you choose that, you have this, right? You have that w can be both of these. It can be minus 1 minus square root of 1 plus a squared divided by a, or minus 1 plus square root of 1 plus a squared divided by a. What one are you going to choose? You can choose this one. Why? Because you notice that it is negative with negative. Now a are values that going we are considering a's from positive values, right? This is the positive values. So a squared plus 1, this number over here is always bigger than 1, even when you even when you're taking the square root, okay? Minus 1, it will give you a positive number, and we need, if you choose this, you will have a negative number for w. If you have a negative number, you will have a line with a slope decreasing, right? But our line, we wanted in a positive line, okay? So this is why we need to choose this one over here, okay? So now we have this information for our linear coefficient, it's big, and we have the other information that it passes through the point 0 and 0 because this line over here goes through 0 and 0. So our b equals 0, right? If you make it y equals wx plus b, well, 0 and 0, so 0 equals w multiplied by 0 plus b, so b equals 0, okay? So let me just take over here. So what can we do now? We are going to say that our third line is y is equal to all this big stuff over here as our w minus 1 plus the square root of 1 plus a squared, put a squared over here, wrong, a squared divided by a multiplied by x. This is this line over here, okay? And now we have our three lines. So I wrote over here the equation for each line that we just found, okay? Now notice for this black line over here, okay? For the black line, this was the equation. For the rising line, the blue rising line, this was the equation. For this falling one, this is the equation. Okay. So how do we proceed from here? It's by remembering what is the question. What do we want? We want when a is approaching this point M. So what is happening when a is approaching M? It is the a. Now this point is a, big A, but this a over here, the linear coefficient of this angle is going to 0, right? What happens when this linear coefficient of a is going to 0? What happens to the point P? So this is the question. So how do we compute, how do we talk about the point P now? It's by noticing that the point P is part of the both of this line, of the black line and of this falling line over here. It is the intersection. So how do we find this point P? Well, it is the same y. So this y over here, when it is in the point P, minus 1 plus the square root of 1 plus a squared divided by a must be equal to this y over here of the second line, right? Minus ax plus 2am. What is this given us? Remember, this is the y's. We can say that they are equals. When are they equal? When they are in the point P, because they both share this point P. When we are going to find, when we're doing this, we are finding an x. What x is this? It is this x over here. It is the x of the point P, okay? So how do we find the point x? There is an x over here also, right? Because this x over here, it is multiplying x, okay? So let's join them over here. Minus 1 plus square root of 1 plus a squared divided by a multiplied by x plus ax equals 2am. Okay, now I'm going to take the x outside. So x is equal to what? To this minus 1 plus square root of 1 plus a squared divided by a plus a, okay? If you multiply the x inside, you will get this back. It is the same thing. Divide by, over here it's is equal to 2am, okay? How do we continue? Now I want the x alone, okay? Because I want to analyze how this is the x of p, okay? This is the x in the point P, of the point P. So 2am divided by all this, okay? Now I'm just going to join them in the same base over here, okay? So I'm going to say minus 1 plus square root of 1 plus a squared plus, now in place of a, I'm going to say a squared divided by a, so I can put them all in the same base, okay? I just took of this dividing over here and I joined them in the same base, so squared. Okay, this is the same thing. So x of p, this part is going to multiply, is equal to 2a multiplied by a is a squared m divided by minus 1 plus square root of 1 plus a squared plus a squared. Now, just to make it better, x of p is 2a squared m. Now, I'm going to say a squared minus 1 plus square root of 1 plus a squared, okay? So this is our x of p. Now, notice, this is the thing that we want to analyze. When are we analyzing it? In this point. When a is going, when this linear coefficient a is going to 0, what happens to x? Does it go to c? Does it go to m? Does it go to 0? This is what we are analyzing. So what am I going to say here is that the limit when a is going to 0 of x of p. This is what I need to find. So let's find now our limit. Okay, our limit when a is going to 0 of x of xp. Okay, so remember, so look how I'm going to write it now because it's important. Okay, now this part is limit solving. Okay, so square root of 1 plus a squared. Now I'm going to say it is minus, okay, 1 minus a squared. Now just if you got lost in this algebra over here, what did I just do? I took this part over here, put it in the initial. It was a squared minus 1, so I put the minus outside. So notice, if you multiply the minus in, it will be minus 1 plus a squared, exactly as I had it. I didn't use anything of limits now. Why did I do this? Notice, if when a approaches 0, if you just put 0, like if you say 2 multiplied by 0, m divided by, well, a squared going to 0, so 0, square root of 1 is 1 minus 1 minus with minus plus 0, so it will be 0 divided by 0, right? And this is undetermined, so we need to make some modification in this one to solve it. Okay, so the one I'm going to use is 2a squared m divided by the square root of 1 plus a squared minus 1 minus a squared. Now notice, if you call like let's say x, if you give x this value over here, x is minus 1 plus a squared and y is 1 minus a squared. Okay, remember that x minus y multiplied by x plus y is equal to what? Is equal to x squared minus y squared, right? This is the same over here. We have something minus something. So what I'm going to do is multiply it by 1. But how? By 1, because if I multiply it by 1, I'm not changing anything. But I'm going to do this one a bit different. So 1 plus a squared plus 1 minus a squared. Okay, so this part over here is 1, but when I'm multiplying over here, we have this part which is something and this part which is something minus, and this part here is the same as this plus this part over here the same as this. This is the same formula as we had this over here. Okay, so it's going to be this squared. So over here 2a squared m divided by this part squared, so it was the square root, so it will be just it, minus this part over here squared, 1 minus a squared squared. Okay, because of this formula over here, perfect squared it's called. Okay, if you want to train it. So how do you solve this? Well, 2a squared divided by m 1 plus a squared minus, well, this square root will be the double of the first, minus multiplied by minus plus 2a squared plus the square root of this, the double of the second multiplied by this. I'm just doing it fast, so but you can do it by yourself, right? The algebra is not the focus, so it will be minus a4, okay? Plus 1 minus 1 cuts, right? And here we'll have that 2a squared m divided by 3a squared minus a to the fourth, okay? Over here. This is what? This is our x of p, okay? I'm just getting rid of the undefined. So by taking this over here, 3 minus a squared, okay? I took a squared outside. If you multiply it over here, you get back, just so that I can cut a squared over here. So I'm going to have 2m divided by 3 minus a squared. Why did I do that? Because now I can solve it. Limit when a goes to 0 of 2m divided by 3 minus, I feel that I forgot some 2 over here. Ah yes, I forgot the whole part actually. Remember that we multiplied above and downwards, right? So I forgot to carry this with me, okay? This over here would be multiplying over here. 1 plus a squared plus 1 minus a squared. You can't forget this as I did, okay? So it goes with me. 1 plus a squared plus 1 minus a squared. I used the down part to get rid of the square root over here, but I carry it with me upwards. So over here too, we have 1 plus a squared plus 1 minus a squared, okay? So it is the limit of this multiplied by 1 plus a squared plus 1 minus a squared, okay? So when a goes to 0, we will have that it is 2m, well, square root a goes to 0, so just m, plus this goes to 0, so it is plus just 1m, divided by 3 minus 0, so it's just 3, okay? So the square root of 1 is 1, plus 1 is 2, multiplied by 2 is 4. So this limit, when a goes to 0, of x of p is equal to 4m divided by 3. And this is what our x of p, this is what our x is going to approach, okay? It's going to approach to 4 divided by 3 of m, okay? It depends on this m over here. Oh, hello everyone. This is the end of the video for you. So I did here the equation, so notice that the red line for x is smaller than, I can say, and bigger and equal to 0, right? Because I only care for this first part. And here I can say it is smaller or equal to 0. Wait. Yeah. Let's just go straight to the point. Smaller or equal to 2. Here. Because we only care about this part. So this is the formula for the blue one and the formula for the red one, and this purple one is the bisector. I'm using here m equals 1 now, but you can variate it, but of course you will need to vary 2 over here, so let's just use 1 as an example. Remember, we found what this point over here would tend to be 4 divided by 2 multiplied by m. As m is equal 1, so it will tend to be 4 divided by 3, right? When a approaches 0. And you can see that it actually does approach over here, 1.333, okay? So this is the formula for the purple one over here, okay? The formula for the purple one. This is the formula for the x, right? For the x when x is cutting over here. You see this black line over here? It is the formula. He goes where these lines intersect. This is the x of p that we used to find the limit. We used to find when limit of a tending to 0, what happens to this x of p. Okay, and this is, these over here are the points. Okay, they are the point p, this red one. So we can actually see it. We can see it when a is moving, what's happening to it. Okay, so you can see what it goes to 1.33. You see it? It goes to 1.33. So how did I compute this point p? Well, the x part is already ready, right? Because the x part is the x, this one over here, it's the black line. So how can you find the y part? Well, you just put it in the blue formula. You have it in the blue formula. Where is the blue? In the blue formula, minus ax, and you use the x of the black line plus 2am. Okay, so yeah, plus 2am. You see, this is the y because it makes part of the blue line. Okay, so you can do this. Now let me just go back because I don't want to use the m over here. But you can use, like, if m changes, there is no problem. Okay, if m is changing, you just need to remember, like, if m was 2, remember what point it would tend to be. It will be 4 multiplied by 2 divided by 3, right? So look, it doesn't mean anything. Look, you see, 2.666, 4 multiplied by 2, which is m, divided by 3. And you can even make the m goes on variating here. You see, for m's variating, it varies together. So very nice.